Welcome guys to my YouTube channel, and let's start off guys to solve this question. I read the question: determine Fourier series defined by the function. Guys, we have a simple function here which is x from negative pi to pi and x plus 2 pi, which means it has 2 pi as its period. And so guys, we now start off. As you can see, the first thing guys going to do is to draw the graph. And the graph is very simple. We just have to put x negative pi and pi. So when we combine those two dots with a line, that is our graph. So our graphical representation is right here. As you can see, it's symmetrical along the x equals to y axis. And so we now continue. And this means, guys, is an odd function. This is an odd function. And so therefore, guys, we shall have this will be 0. In other words, an will be 0, and also a0 is going to be 0. And so therefore, we shall be left with this. But guys, we can still go ahead and look for them and see what we get, whether we get 0. So a0 equals to that. And guys, I integrate that. So after I integrate that, x becomes x squared over 2. You put negative pi and pi. And by so doing, guys, this is what I have gotten. As you can see, I've already gotten the 0 I was talking about. Guys, now we go to the an. For the an is represented by that. Guys, we have already done this equation. Yes. And you will see it where I am saying that you prove this is equals to 0. So guys, I may not repeat all that. You just have to look at that. And guys, this will come, all of this will come to 0, will end up being 0. Because remember, this is an odd function. And so guys, you can see my 0 right there, an equals to 0. Let's now go to bn, which we are going to concentrate on. Bn is equals to 1 over pi, integral from negative pi to pi, x sine nx dx. Guys, we use the integration by parts. So u equals to x, then du is 1 dx. dv is sine nx dx, and v is that. Guys, we come and fix. That is in our equation. This one is already there. Now we fix u and v. So guys, this is our u there. This is our v. U is x, v is negative cos nx all over n, and the negative is right there. And here we have the v du. V is 1 dx, and du, that is du is 1 dx, and v is negative. So that negative causes this to be a plus. And so finally we have this equation. And as we have already said, sine nx becomes 0. So guys, we are left with this term only. And of course, we have 1 over pi. So with that, we just come and fix our lower limit and our higher limit. Our higher limit is negative pi here. We have negative and then pi cos n pi. The n, we have put it right here. This is the n where we have taken the n. Minus, this minus is always there. Then you have this minus, and then minus pi cos n pi. So when we do that, guys, this is what we get. All this becomes negative, because this will be positive. This will be negative here. Here we have 3 negatives, which produces a negative. So this is going now to be 2 pi cos n pi, like that. And then we can factor out. The n is already factored out. We can come and now cancel the pi's. We are left with negative 2 all over n cos nm, of which, guys, this comes to this. The bn comes to that. So, guys, it's now just to fix our figures in our equation. And our equation is right here. As we said, this term is 0, this term is 0. So we are left with this term. So in fixing that, guys, we start with 1. For 1, you have negative 1. Here you shall have negative 1 and negative 2. This becomes 2. All over 1, sine 1x. This is 1x minus, you can put 2 there. This now becomes positive, so you will have a negative here too. All over the 2 you have put sine now 2x. Now you go to this, if you put 3, this one is still negative, and negative becomes plus 2 all over 3 sine 3x, and so on. And so, guys, our solution is right here. And even this one was also correct. This is our Fourier series. So, guys, thank you for listening to me. Bye.